Okay, we're going to go over the geometry EOC practice test session 1. I'm going to try and do this as quick as I can. And again, if you need to rewatch it, it'll be up online. All right, session 1, this was the non-calculator part. So every question on this section should be able to be done without a calculator. Let's go ahead and take a look at the first part of it. So again, these couple sheets there at the beginning, these are your reference sheets. Both of the reference sheets are ones that you'll see on the FSA. Again, they might not be as helpful as the equations you want. So you need to make sure that you're studying for all the other formulas that we had from throughout the year. Okay. On number 1, we have a question that is select all that apply. On any select all that apply question, you should always select more than one. If you're only selecting one, you're basically saying that you're getting the question wrong, because I've never seen a select all that apply where there's only one correct answer. Now, on number 1, it says, select all the conclusions you can draw if you know that angle 1 is congruent to angle 8. So looking at the diagram, angle 1 and angle 8 are congruent. What that's telling us is that these two lines are parallel. So since these two lines are parallel, that means that every single angle that's on those two lines cut by this transversal P is either congruent or supplementary. So all the acute angles, 1, 4, 8, and 5, are all going to be congruent. All the obtuse angles, 3, 2, 6, and 7, will all be congruent. Any combination of one acute and one obtuse is going to be supplementary. So looking through those answer choices, we have for A, angle 3 and angle 8, 3 and 8. One's obtuse, one's acute. That doesn't work. For B, angle 6 and angle 3 are congruent. 6 and 3, both of them are obtuse. I have them labeled as congruent. That one works. A and B are parallel. That's correct. Again, the reason why they're parallel is since 1 and 8 at the beginning were marked as congruent. That means that these were alternate interior angles. And if alternate exterior. If alternate exterior angles are congruent, then the lines are going to be parallel. So we have that one definitely worked. Going down to D, 5 and 4. 5 and 4, those are alternate interior. And again, they are congruent. So that works. And then the last one, 7 and 2, add up to 180. Well, 7 and 2, both of those are obtuse. Those two should be congruent. They do not add up to 180. You can never have two obtuse angles give you 180. You also can never have two acute angles give you 180. All right, the next one, number 2, it says a square has vertices at points, and they gave us 4 different vertices. So if we graph this, again, on the EOC, you'll have graph paper on the last page of your scratch paper. Make sure you use that if you have a question where you need to graph. If you need more graph paper, always just ask for more. So we're going to graph these. Now, they don't actually give us values for all the parts, but they give us 4 values with A and negative A's. So we can just call this A and negative A on our x-axis. This can be A and negative A on our y-axis. So we have points of A0, of 0A, negative A0, and 0, negative A. Together, they're going to make a square. Now, graphing helps. Looking at the options right away, I see B, AA would be out here. That definitely doesn't work. So they want points that lie on the lines. So again, that one's way off of the lines. Doesn't work. Then we had option D, Also, definitely doesn't work. 0 and then half of A, we right about there. So D doesn't work. And then E, kind of like A, also doesn't work. Negative A, positive A, way up there to the left, doesn't work. So just to make sure you know which points are which, this is B, this was D, and this was E. Now, the two that do work are A and C. If we were to graph A, we got half the distance in a negative direction, and then half the distance in a positive direction. And we end up right on the line, and this was the point for A. Then we had for C, positive direction and positive direction right there. This would have been C. And again, both A and C are on the lines. Let's clear that, move this up. Oops, too far. Try again. All right, so now we have 3. This one, it just wants to know which two statements are contradicting each other. If you look at the options, the first one says angle 1 and angle 2 are complementary angles. That means that they add up to 90. So measure angle 1 plus measure angle 2 equals 90 degrees. Then on number 2, it says measure angle 1 is 50. Well, if angle 1 was 50, angle 2 could be 40, and it would equal 90. So those don't seem to be contradicting. 1 and 3 are going to be the two that are contradicting each other. Because on number 3, it says these 3 angles together equal 180. But angle 3 is not 90 degrees. Well, if 1 and 2 are 90 degrees, the only way for all 3 of these to add up to 180 would be if 3 was 90 degrees. So on here, 1 and 3 can't happen at the same time. Now, on to number 4 and 5. On number 4, it says a food court is investigating which paper cup to use for its water fountain, which best compares the volumes of cup A and cup B. So they gave us some dimensions of each of our cups. Both cups are in the shape of a cone. So we're going to use our formula for a cone, which is 1/3 base area times height. Or if we want to be a little more specific, 1/3. The base area on this one is a circle. So pi r squared. And then again, times height. For these, we have a height and a radius given to us in terms of r on both of these. So the first one has the radius of r, a height of 2r. So we're going to plug those in. So for the first volume, for figure A, we have 1/3 pi r squared. All right, sorry about that. All right, so again, we had r was r for our radius here. So it went in, still is r. Our height is 2r. So we plugged in for the height, 2r. And now we need to simplify. Now we still have the 1/3. We still have our pi, r squared times 2r. Well, multiply the two r's together. So that becomes r to the 3rd. This 2 can be multiplied with the fraction out in front, so it becomes 2/3 pi r cubed. For the other one, so it's going to be volume, change color here. Volume for B, we're going to have 1/3 pi. This time the radius is 2r squared times the height, which is r. Well, this one's definitely going to be bigger because we're squaring the 2r. So now both of those values get squared. So 2 squared is 4, and then r squared. Now, the 4 can be multiplied with the 1/3, which gives us 4/3. We still have pi, and r squared and r gives us r to the third. So the only difference between those values is we have 2/3 in front of the first one. We have 4/3 in the second one. So we could either say that B has twice the volume of A, or A has half the volume of B, which is answer choice D. Now, number 5, in the figure shown, what is the value of X? So first, they gave us enough information to say that these two triangles must be congruent. They told us that these sides, we have 2 sides that are congruent, and the angle that's between them is also congruent. So these 2 triangles are congruent by side, angle, side. Since they're congruent, the corresponding parts have to be congruent as well. So the lengths are equal, which means that 6x minus 1 has to equal 17. So solving that, bring the -1 over to the other side by adding it. That's 18 divided by 6, and x is 3. All right, moving on to the next part. For number 6, down at the bottom. The volume of A is 60. The volume of B is half the volume of A. What's the height of box B? Really, we don't even need the diagram for box A, because they gave us all the information we need for A is that the volume is 60. Box B is half the volume of A. So, well, the volume for B then must be 30. So this one was 60. This one was 30 for our volume. Once we know that, our formula for volume equals, for a rectangular prism, going to be base area times height. Base area for this one is, you can say length times width, or base times height. So these two, 4 and 3, are being multiplied together to find our base area. Our height then is A. Our volume, we already know, is 30. So simplify the one part of our equation. 3 times 4 is 12. Get rid of the 12 by dividing it off. And when we divide that off, it gives us 2.5 for A, which was representing our height. So our answer is A. On the next one. Oops, went too far. Let's try that again. Number 7. On number 7, we have if CF is 3, CD is 18, and EF is 3. What is the perimeter of triangle CDE? All right. On this one, what we need to recognize is we have a perpendicular line coming to the midpoint of CF. Since this is the midpoint, besides CE. So since this is the midpoint, since F is the midpoint of CE, that means that this is a perpendicular bisector. Well, the perpendicular bisector is also going to the vertex on the opposite side, which means that the only way for that to happen is if this is an isosceles triangle. So if this side's 18, this side must also be 18. So now, if they want to know the perimeter, add all the sides up. So we have 18 plus 18 plus this side was a total of 6. So that's going to give us 42, which is D. On number 8, they gave us some points. It says point N prime is at 7, -8. It's the image of point N, which was 7, 8, under a reflection. What is the image of -4, -10 under the same reflection? We'll just look at how they changed. The Y value changed signs. That's the only thing that changed. So if the Y value changes sign, it must be a reflection in our x-axis. We're going to apply the same reflection over here. So the only thing that should change is our Y values. So if we had -4 and -10, the -10 becomes +10. So -4, +10, which is A. All right, going to number 9. Let me scoot this up just a little bit. On number 9, we have a couple of different triangles there. The most important thing to this one is the fact that this triangle that I'm highlighting is a 30, 60, 90 triangle. We want to know what the side BC is. They give us the length of BD. BD is 8^3. Well, this goes back to the idea of a special right triangle called a 30, 60, 90. So I'm putting the property over here off to the side. We have the shortest leg is normally referred to as X. The longest leg is usually X times the square root of 3. And then the hypotenuse is usually the short leg times 2. So on this one, we have 8^3 for our long leg. The short leg then would be just 8. So we had to divide off that ^3. And then finally, the hypotenuse, 8 times 2 is 16. So that leg is 16. That's our answer. All right, clear. On the next one, number 10. A plane intersects a rectangular prism shown below through the vertices B, D, F, and H. So we have B, D, F, and H. Well, if I trace that out, you might be able to recognize what shape it is. Now, it is going on a diagonal here, so it might be hard, but these are all right angles. So this is a rectangle. On number 11, we have a triangle with an altitude drawn in. So there's some special properties that we had, 2 equations that we had earlier in the year. So we're going to write them out. They're using geometric mean. The altitude was equal to the geometric mean of part 1 times part 2. The leg was equal to the geometric mean of the adjacent part times the whole. Oops, I wrote that wrong. Let me try that again. Said it right, wrote it wrong. Adjacent part times the whole. Again, anytime we say geometric mean, what we're doing is we're taking the two values, we're multiplying them, and then taking the square root. So on the first one, we have the altitude is this piece here. Then we have the legs. We call this leg 1. Call this leg 2. So then this one that's next to leg 1, I'm going to call part 1. The one that's next to leg 2, I'm going to go part 2. So again, those are the two parts of the hypotenuse. And then we have the whole hypotenuse. So they want to know the length of first HK. Well, HK is our altitude. So plugging in, we're looking for the length of HK. So we're doing the geometric mean of the two parts. The two parts here are 2 and 8. 2 times 8. 2 times 8 is 16. The square root of 16 is 4. The only one that has the correct answer there is B. If we want to check the other one, we can check the other one as well. So we also want a GH. GH was a leg, so I'm using the adjacent part, which would be the 2, and the whole, which is these two together, which is a total of 10. So we have the square root of 2 times 10. 2 times 10 is 20. And then we can reduce that by separate it into 4 and 5. The square root of 4 is 2. So 2 radical 5, which is the other half of answer choice B. All right. On the next one. Number 12. Let's get this up just a little bit so we can get more on the screen. Well, I'll have to do this one first before I can move it up. So number 12, which of the following figures could have a cross section in the shape of a triangle with a plane that is perpendicular to the base? On the first figure, number 12, any plane you put perpendicular on here would end up as a rectangle. On B, which again, it gets kind of confusing because the letters are off the bottom here. So these letters go with those figures. B, same thing. Any type of prism, always going to give us a rectangle if we go perpendicular with the base. For D, this was an oblique prism. So this one could either give me a rectangle or a parallelogram. The only one that can give me a triangle is the pyramid. If I went straight through the top, I'd end up with a triangle. So just imagine falling right down these sides, cross through the middle, and back up to that point. We'd have ourselves a triangle. Now, for number 13. This one, there's some things I don't like about the way they labeled it, but given what they have, this piece is 200. They know that angle 1 is 35, which means this angle across from it is also 35 because those are vertical angles. The 35 with angle 1 and either of these other two could make a linear pair, which would make them supplementary. So subtract the 35 from 180 and we'd be left with 145 for these other two angles. Now, they want us to find LM. LM is this arc down here. So there's a equation that we had for one interior angle. We had lines intersecting inside a circle. You could find the measure of these two angles by taking the average of their intercepted arcs. So arc 1 plus arc 2 divided by 2. Well, we know the interior angle is 145. We know that one of the arcs is 200. We don't know the other arc. That's what we need. And it's over 2. So now solving the equation, bring the 2 over by multiplying, because that's 290 equals 200 plus x. Subtract off the 200, and we have 90 equals x. All right, moving on to the next one, we got 14. It has endpoints, and it gave us the endpoints for A and B. What is the y coordinate of the midpoint? They don't ask us about the x value at all. Anytime you do midpoint, you're doing the average of the x's. Oops, I didn't need a big parenthesis there. So we have the average of the x's and the average of the y's. And that's how we come up with the x and y value of the midpoint. Well, we don't need the x values at all. They're only asking us about the y. So we're only using the y values of 3 and -1 in our equation. So I have -1 plus 3 divided by 2. That's 2 divided by 2, which is 1. That'd be the y coordinate of our midpoint. Number 15, we're talking about equation of a circle. X minus h squared plus y minus k squared equals r squared. They told us the center, which is our h and k value, is at -3, 5. When we plug them into the equation, we have negatives already, so the signs have to change. So for the h value of -3, this will become +3, so x plus 3. Looking at all of our options, A doesn't work because it doesn't have the right thing, as minus. Same thing with C. Then we move on to 5. You have a +5. Again, plug it in, becomes a -5. So again, A and C have the wrong sign. And it says we have a radius of 4. When I plug 4 into my radius, it gets squared. So 4 squared is 16. So first two A and B are out. The only one that has all the correct parts is D. On number 16, we're dealing with inscribed angles. So first, they give us an inscribed angle as 85 degrees. The arc it intercepts then has to be double the inscribed angle. So if that's 85, this arc is going to be 170. Then on the other side, we have this little arc. We have the angle, which is our inscribed angle, is 35. So the arc has to be double that. It has to be 70. In order to find our final value, we're taking the 70 and the 170, adding it up and subtracting it from 360. So 360 minus 240 leaves us with 120. That's that missing arc. All right, moving up. Number 17. By which theorem can you conclude that these two triangles are congruent? Well, all the options down there are ones that do work for congruency. There is one missing, which is AAS. But which one of these correctly identifies that these two triangles are congruent? We have a side, we have a side, and we have an angle. But does sides angle work for similarity or congruency? No, again, spell something bad backwards. So that one doesn't work. However, there was an exception. HL. If we have a hypotenuse and a leg, and here we have a right triangle, so we have a hypotenuse and we have a leg, then we know that the two triangles are congruent. So B is the answer. '18 and '19, you can skip those two. They threw them out. On 20, I thought 20 was kind of confusing when looking at the diagram. It's hard to tell what was labeled as what street. Let me zoom in on this one. So now on this one, they want to know which street is parallel to Second Street. Well, this street here is Second. So right away, Elm Avenue and Main Street are out. They're definitely not parallel. We want parallel. Parallel means it has the same slope. So pick 2 points that you think look very close to going through the same thing. Here I got these 2 points. I'm going down 5 units and over 2 units. So I need to find a line with the same slope as Second Street. So find a point you think it goes through, and then count down 5 over 2 and see if it comes back to that line. 1, 2, 3, 4, 5, 1, 2. Nope, not even close. Go to the next one. Find a point that looks like it goes through, and count down 5 and 2. 1, 2, 3, 4, 5, 1, 2. Again, doesn't look like a very good fit. So try the last one. Here's a point. 1, 2, 3, 4, 5. Over 2, 1, 2. And that one looks like it worked. So this street is 4th Street. All right. Let me zoom back out. Oops, too far. That was all for that page. So now, number 21. This one, it's kind of hard to demonstrate on here, but the idea is when you're copying an angle, first you have to start by putting your compass on the vertex and swing an arc through both sides. And then you bring it down to the other line, start from one of those points, and then swing that same size arc through the line and high enough so that it would go through the other line once it's congruent. So what was the first step? A was the first step that we just said. All right. So now on 22, this is basically Cavalier's principle. Cavalier's principle says you need to have the same height and same size cross section at every level in order to have the same volume. Here, we have a stack of pennies and a stack of nickels. Well, although there's more pennies than there are nickels, is the volume the same? The answer is no. Because yes, they might be the same height, but their cross-sectional base area is not the same. A nickel, if you looked at a nickel and a penny, a nickel is bigger. So it has more base area in the stack. So right away, look at the answer choices. Since we know this doesn't work, we can cross off the 2 yeses. and it's between A and B. The two stacks have the same height, but there are more pennies than nickels. That has nothing to do with property. The correct answer is B. The two stacks have the same height, but the area of the cross-section of a penny stack is smaller than the area of a cross-section of a nickel stack. All right. Bring this up as much as I can. So number 23, it says, why can you not say that two vertical lines have an equal slope? Well, vertical lines have an undefined slope. So since they have an undefined slope, my answer must be A. On number 24, you had to say which one of these were correct. It looks like I still have lines on here from the last thing, so get rid of those. All right. All of the answer choices are based off of A. So label it based off of A. I have a piece that's opposite. I have a hypotenuse, and I have an adjacent. Sine is equal to opposite over hypotenuse. Well, opposite was 10, hypotenuse was 26. That reduces to 5 over 13, which is option A. So that one works. Now we're going to do cosine, which is adjacent over hypotenuse. Adjacent is 24. Hypotenuse is still 26. Now that is 12 over 13. 12 over 13 is the same as option B. So that works. Now notice, there was another sine and cosine down here on D and F. Those two have values that don't work. So D and F are not right. A and B are. Now we're down to the two tangents. Tangent and opposite, so 10 over adjacent, 24. That reduces down to 5 over 12. So F is correct. C is not. All right, on 25. Lines M and N cross to form angle 1, angle 2, angle 3, and angle 4. Draw a picture. Angle 1 is 30 degrees. So I'm going to call this 1. I'm going to label it 30 degrees. It told us that 1 and 4 are supplementary, so they must be a linear pair. And 1 and 3 are vertical angles. So this is 3. And then finally, this other one must be 2. So on here, it wants to know the measure of angle 2. You can do this a lot of ways, but 1 and 2 together form a linear pair. So 180 minus 30 leaves us with 150, which is option D. All right, next one. All right. On 26. The vertices, and they give us a bunch of vertices. What is the most precise classification of that quadrilateral? There's 4 points, so this should be quadrilateral, but graph it so you can see it. Negative 1, 1. So negative 1, 0, I mean. Then 1, 6. And 5, 6. And then the last one, 5-2. All right, so those are all connect the dots. Just looking at this, the shape that it's in, it looks like a kite. So I think it could be a kite, but we got to go back and check it. It definitely is a quadrilateral. Parallelogram, no, doesn't have two pairs of parallel sides. Trapezoid, nope, doesn't even have one pair of parallel sides. So quadrilateral or kite are the only two answers. In order for this to be a kite, we have to have two pairs of consecutive congruent sides. Find the difference between these two. This length is 4. Find the difference between these two, and this side is also 4. That's one set of congruent sides. For the other part, if we count the difference, you go up 6/2. And you go over 6 up 2. Now, you could use Pythagorean theorem or distance formula, but since we have the same two legs on each of those, they must be the same distance. So they must be congruent, and therefore this must be a kite. On 27, a rectangle is rotated about one of its sides. What three-dimensional figure would it generate? So if I had a rectangle, and let's say I rotate it around this line. Well, I'm going to get the same thing on the other side, but it's going to do that by going in a circular motion. There and around. Same thing on the bottom. There and around. And again, this is a cylinder, which is option C. Number 28, select all types of lines that intersect. Select all types of lines that intersect and are coplanar. Well, parallel never intersect. Perpendicular lines are going to be on the same plane. And it's like all types of lines that intersect and are coplanar. So I think I said the right thing, but I crossed off the wrong one. That's why I'm kind of confused there. Cross off parallel. Perpendicular is the one I said it can't be. Segments, that doesn't make sense. Transversal, nope. I feel like the only one that really works well here is going to be parallel. Let me use that other thing. All right, and 29. What is the equation of a line that is perpendicular to the line? So first thing, we want perpendicular. So this is our slope of the original. We want perpendicular. So we're going to do positive 1/3. Then we want it to pass through this point, 6, 8. So we can use our equation. Oops, it's supposed to be a y. Y minus y1 equals m times x minus x1. Now, we already know our slope is 1/3. Our point is at 6, 8. So y minus 8, x minus 6. Now, this is not in any of the formats that are over here. All the answers are in slope intercept form. This is in point slope form. we need to simplify and get y by itself to get it to slope intercept. All right, so we have y minus 8 is equal to 1/3. I'm distributing here 1/3 x minus 2. Bring the -8 over to the other side by adding it. So B is the correct answer. Wait. Nope, I lied. I added the 8 and the 2. Erase. So when I add the 8 to the other side, it becomes +8. So the difference between +8 and -2 is +6. So take that back. D is our answer. All right, 30. We're almost done. What are the coordinates of the point 4/5 away from A to B? Well, we went 5 units over and 5 units up to get from A to B. So if we went 4/5 of the way, instead of going over 5 and up 5, we're going to be going over 4 and up 4. Is that the point? 4, 4. All right, let's move this up. All right, on 31. And the figure shown, if measuring 1 is 112, what's the measuring angle 6? Well, 1 is an obtuse, 6 is an acute. Together they have to be supplementary since these lines are parallel. And it gave us that marking over here. 180 minus 112 is 67. So 67 degrees is our answer. And then number 32, which I think is the last one on here. It's like all the statements that are always true about A, B, C, D. We have to know what figure we have, the parts that are labeled, the two that are across from each other. That's enough to know that this is a parallelogram. Now, it could be a rhombus. It looks like a rhombus. However, we don't have the markings for a rhombus, so we can't assume it's a rhombus. ABC, angle at the top, and CDA, this angle down here. It says they are congruent. Well, that would always be true because opposite angles are always congruent in parallelograms. BD is perpendicular to AC. Sounds good, but that would be specifically for a rhombus. And we don't have enough information to say this is a rhombus. BE and DE are congruent. That would be true. Then we have the same two triangles, sorry, the same two angles that are labeled here. It says they add up to 180. Well, that would be impossible since they're both obtuse. So that doesn't work. And then finally, AB is congruent to CD. Those are opposite sides. Opposite sides have to be congruent in parallelograms, so that one's also true. That's ACE. I think that was the last one for this section. Oh, no, I was wrong. 2 more questions. Move this up. We have to do these one at a time. All right, 33. How can you construct a line through C parallel to line M? All right, so they're looking for a line to be over here, parallel to that one. Now, we could do a lot of things with the different parts of these angles in order to ensure that they're correct. First, it says construct a line through point C, perpendicular to PB. Doesn't have to be perpendicular, that one's out. Copy PBA at point C with one ray of the angle on AC. He's sounding pretty good. We'll come back to it. Construct perpendicular bisector BC. That doesn't do us any good. And then D, construct the midline of triangle. There's no triangle in that diagram, so that makes no sense. B is the correct answer. And finally, 34. Which theorem is illustrated below? So angle 1 and angle 3 are supplementary. Angle 2 and angle 3 are supplementary. Angle 1 plus angle 3 plus angle 2 plus angle 3. So they're equal. Angle 1 and angle 2 are equal because they're able to get rid of 3. And finally, if they're equal, they must be congruent. So they started off with 1 and 3. And then they prove these through being supplementary. Those are either what we call same side interior angles or consecutive interior angles. Sorry, let me finish explaining that. So angle 1 and 3 was where we started off. Those were same side interior angles. Again, we used that property. We also used a couple of other properties in here, like linear pair for number 2. We use properties such as angle addition, or sorry, not angle addition, transit property for number 3. We use subtraction property for step 4. And then finally used the idea of angles that are equal must be congruent. So that's definition of congruent angles. So this was like a proof. What do we go from and to? Well, in the end, we're able to say that 1 and 2 were congruent. So our final thing, oops. Actually, I'm going to erase those other 2 that I circled for now. So erase the starting part. And so 1 and 2 is what we ended up with here. Those are alternate interior angles. So A is what we actually proved through that illustration and that semi-proof there. That is it. I will probably wait to make another video until tomorrow. So I'll post this one, and after that, I'll post the other one tomorrow.